Okay, welcome back everyone. This is 4.1, simplifying rational expressions and finding domains of rational functions. So if you're given a problem like 5x minus 20 divided by x squared minus 1x minus 12, first thing you need to know is your domain is always located in your denominator. That's where we would find our domain. And then in order to work these problems, to simplify them down, we're going to treat them as individual problems. So I would start out with numbering them 1 and 2, and we're going to work with number 1 first. It says 5x minus 20. Notice that they both have a GCF of 5. So 5 came out, x minus 4 is left. Then we go to number 2. It says x squared minus 1x minus 12. Think of Colombian method of factoring, square root method property, whichever factoring form you know. So dump the x's, split them. So I added x and x. First coefficient and the last one is negative 1 times negative 12 is negative 12. We're going to look for numbers that give us negative 12 by multiplication and add a negative 1. Well, the products for 12 are 4 and 3, 6 and 2, 1 and 12. But 4 and 3 are the ones that will get us to a negative 1 if the 4 is negative. So negative 4, positive 3. So here's where our domains would be located. So I can be everything except where x does not equal a positive 4 and x does not equal a negative 3. So all reals except x equal to negative 4, positive 4 and negative 3. But the problem wants us to simplify this. So first thing, we're going to put these back together. So the first one factored out to 5 times x minus 4, and the second one became x minus 4, x plus 3. Cancel out the common values. So those cancel out, leaving you with 5 in the numerator line, x plus 3 in the denominator line. So for those of you doing your whatever independent homework system you're using, the numerator line would be the 5, the denominator line would be the x plus 3. It's easier to put everything in parentheses just to be on the safe side. Next example, it says it's x squared minus 6x plus 8 over x squared minus 5x plus 6. So the numerator line is going to be known as the f of x. The denominator line is known as your g of x. Again, we're going to number it 1 and 2. We're going to work with number 1 first. So it says x squared minus 6x plus 8. Again, parentheses because we're factoring. Split your variable x's because it's an even exponent. First times the last is an 8. The product is 8. Needs to add to a sum of negative 6. Well, 8 is 4 and 2, 1 and 8. 4 and 2, if they're both negative, you get negative 6. So negative 4, negative 2. Then we go to the second one. And the second one happens to be x squared minus 5x plus 6. Again, we are factoring. 2 parentheses, split your variables. First times the last is a positive 6. And needs to add to a negative 5. Now, positive 6, that can be negative 6 and negative 1. Negative 3 and negative 2. And the reason I picked negative values is because the sum has to be negative 5. And the product has to be a positive number. So if I'm positive at the top, it means both values have to be positive. If I was negative at the top, then I would be a plus minus situation. So negative 3, negative 2 will multiply to be positive 6, and they will add to be negative 5. So negative 3, negative 2. Then bring your pieces back together. So we have x minus 4, x minus 2 over x minus 3, x minus 2, and cancel out your light pieces. Your x minus 2's cancel out, leaving you with x minus 4 over x minus 3. The x minus 4 represents your f of x, and the x minus 3 represents the g of x, depending on which homework system you're using. Next example. Again, it's another factoring problem. So again, number it 1 and 2. We're going to treat number 1 independently of number 2. So we have 3x squared minus 10x minus 8. Now in this situation, because there's a 3, this is what would be true Colombian method. So if you do 2 parentheses, that first leading coefficient, you're going to write it into each of them and split your variables. And then it's the first times the last. So we get negative 24 as the product. And the sum has to be negative 10. Well, to get to 24 and 10, I can only use 12 and 2. That's the only way to get a value of 10, because 24 is 3 and 8, 6 and 4, and you will not get to a 10 if the 24 had to be negative. Remember, if it's negative, it's a plus and minus we need. Take a negative 10, the 12 is negative, the 2 is positive. So I'm going to write negative 12, positive 2. These are both divisible by 3. So I get x minus 4, and then the second one slides down. There's number 1 factored. Then we go to number 2. The second one is 3x squared plus 14x plus 8. Again, 2 parentheses. So 3x, 3x. The first times the last. Now I'm a positive 24 at the top, which means I'm both positive values, because I need to add to a positive 14 at the bottom. So 24, 12, and 2 again. If they are both positive, we'll give you 14 and multiply to be 24. So positive 12, positive 2. These are divisible by 3. So I get x plus 4. And then 3x plus 2 slides. Now, again, group it back together. So we factored out and we had x minus 4, 3x plus 2. Denominator was x plus 4, 3x plus 2. They both have x plus 2, 3x plus 2, and 3x plus 2 in common. So we're left with x minus 4 over x plus 4. Next example. So in this one it says find the domain of the functions f of x. It says x plus 2 over x squared plus 8x minus 33. Remember, the domain is located in your denominator. This is where the domain is found. So I'm only looking at the bottom equation. X squared plus 8x minus 33. I'm going to set that equal to 0. We're going to factor. So x. 1 and negative 3 is negative 33. So any numbers that multiply to negative 33 that are going to add to positive 8. Well, 33 are only 3 and 11. Now, in order to get a negative 33, I need to be a plus and a minus situation. To get a positive 8, the 3 had to be negative to get me to a positive 8. So I'm a negative 3, positive 11. Solve each one, so I get x minus 3 equal to 0, x plus 11 equal to 0. So x is equal to 3, x equals negative 11, which means these are the values that x cannot represent. If I stick those values of 3 and negative 11 in the denominator, it does not exist. It becomes an undefined situation. So I want everything except where x is negative 3, positive 3, and negative 11. So in any situation, that's what you're looking for. I would be anything in set builder notation. This is what we call set builder notation. It's telling us everything where x, all reals except where x is not equal to these two values. Next example. In this problem, they want us to evaluate the rational function. So they want us to find f of 0, f of negative 1, f of 2, and then the value of x when f of x is equivalent to 7. So we're going to start with the first 3, where we are basically substituting in the variable, the value inside in for the variable x. So they want us to do f of 0. So 2 times 0 plus 1 over 0 minus 5 is what we're doing. We are substituting in 0 for x. So 2 times 0 is 0 plus 1 is 1. 0 minus 5 is negative 5. So f of 0 is equal to negative 1/5. Then they want us to find f of negative 1. So 2 times negative 1 plus 1 over negative 1 minus 5. 2 times negative 1 is negative 2 plus 1. Negative 1 and negative 5 is negative 6. I was short $2, but found $1. I'm short $1 and negative 6. Remember, 2 negatives make a positive. So we're a positive 1, 6. Next one says f of 2. So f of 2, 2 times 2 plus 1 over 2 minus 5. 2 times 2 is a 4 plus 1. 2 minus 5 is a negative 3. So 4 plus 1 is a 5 over negative 3. You can write it as 5 over negative 3, or you can slide the negative up and write it negative 5 over 3. Either one is correct. Last one says they want us to find the values of x when f of x is equivalent to 7. So they're saying f of x is equal to 7. Well, our f of x equation is 2x plus 1 over x minus 5. We are substituting in for f of x. So our problem becomes 7 equals 2x plus 1 over x minus 5. And because of this, I'm going to write this as a fraction on the left and right, and I'm going to multiply by the LCD to both sides. So I'm multiplying the right side by x minus 5, which means I'm multiplying the left side by x minus 5. We become 7 times x minus 5 equaling, those cancel out, so 2x plus 1. We are going to distribute. So 7x minus 35 equals 2x plus 1, and now we're just solving for x. Subtract your 2x to the left. So you get 5x minus 35 equaling 1. Add your 35 to the right. That's the opposite of the sign. So you get 5x equals 36. Then divide both sides by 5. So x equals 36 over 5.